Well, hey there, Yancey. Today we're going to be talking about solving multi-step equations. But before we get going, we got a couple of tips we got to cover. So pay attention! First things first, don't try to do all the steps at once. Take your time, Yancey, or else you're going to get confused. That doesn't mean try nothing, though. That's why our second tip is to try something. Because there's so many different types of equations out there, that means there's no singular set of steps or rules that are going to tell you what to do. So whatever it is you're trying is probably going to be helpful. It also means that the way that we do the problems in this video ain't the only way to do them. So if you got a way that you like better, just shut up and do it, Yancey! Finally, if your equation has fractions in it, don't wet your baby diaper. If you really gotta get rid of them, just multiply everything by the denominator. And if you got more than one fraction, Yance, multiply by the least common denominator. Feeling confused? Well, this'll make a lot more sense when we look at the examples. Looks like we're jumping right into it. Our first example is 2x plus 7 equals 11. Think about what we'd have to do if we plugged in a value for x here. We would multiply it by 2 and then add 7. When we're solving, we're actually trying to work backwards and figure out what the heck it is that we had to plug in. And what's backwards from multiplying by 2 and adding 7? Subtracting 7 and then dividing by 2. Watch and learn, Yance. First things first, subtract 7 from both sides. When we do that, our 7's cancel out over here. We get 2x equals 4. And then we're going to go ahead and divide by 2. Look at that, Yance. 2's cancel out. 4 divided by 2 is 2. That's our answer. Our next example is x over 3 minus 2 equals 1. In this one, we first divide x by 3 and then subtract 2. So when we go to work backwards from this one, Yance, we're going to add 2 and then multiply by 3. First thing, add 2. Weren't you paying attention, Yancey? 2's cancel out and we get x over 3 equals 1 plus 2 is 3. Next thing, we got to take care of that division. And the opposite of division is multiplication. We'll multiply both sides by the denominator 3, and that's going to give us x equals 9. Easy! This next one's a little weird, so hold on to your hats. First, we'd have to multiply x by 5, then minus 2, then divide by 4. So the opposite is to multiply times 4, add 2, and divide by 5. So let's do it! Let's take this denominator 4 and get rid of it. We do that by multiplying both sides by 4. That cancels out our fraction, and we get 5x minus 2 equals negative 3 times 4 is negative 12. Alright, now it's just like the first one. Put it on cruise control, Yance. Add 2, cancel them out. We get 5x equals negative 12 and 2 is negative 10. Think that's hard? Pay attention to our Auducation video on adding and subtracting integers. To get rid of that 5, we divide it, and x is equal to negative 2. Holy crap, Yance. I could do this all day. I could, but I won't. Let's move on. Our next example is 1/12 times 3x minus 1 equals negative 1. In this case, we'd multiply x by 3, minus 1, and then multiply by a 12th. So you might have noticed that the first thing we gotta do is to get rid of that fraction. How are we gonna do it? We're gonna multiply both sides by the reciprocal. That's gonna be the most efficient. You might remember from the beginning that I told you if you wanted to get rid of a fraction like 1/12, you're gonna multiply both sides by the denominator. In this case, it's the same thing. You're gonna find out the difference in a minute, Yance, so for now, let's stick with the reciprocal at 12 over 1. That cancels out the fraction, and we have 3x minus 1 equals negative 1 times 12 over 1 is negative 12. So now what, Yance? Why would you even ask a question like that when you already know the answer? This is the same as the first example. Add 1 to both sides to get rid of that 1 there. We get 3x equals negative 11. To get rid of the 3, divide both sides by 3, and x is going to equal a fraction this time. Don't let that bother you, Yance. It happens. Sick of the fractions yet? Well, boo-hoo for you. Dry your eyes, though, 'cause this one don't have any. In this case, when we plug something in for x, we have to add 20 and then multiply by -2. So to work backwards here, Yance, we gotta divide by the -2 and then minus the 20. But this time we're not gonna divide like we normally do, cause I'm a nice guy and I want you to have options. Dividing by 2 is the same as multiplying by a half. So this time we're gonna multiply both sides by the reciprocal of -1/2. Those two cancel out and we get x plus 20 equals -18. Why? Half of 36 is 18. To get rid of that 20, we're going to subtract it from both sides like I said before, and our final answer is going to be x equals -38. Wow! We even put fractions in this problem, and it was still easy! Remember before I told you I'd tell you the difference between multiplying by the denominator and multiplying by the reciprocal? Well, here goes! If it ain't clear by now, the first thing we want to do is get rid of that 5, 6. If we just multiply by 6, that's just going to get rid of the 6. We're still going to have the 5 there. Want to obliterate a fraction, Yance? You multiply both sides by the reciprocal. If we multiply by the reciprocal, we get rid of the 5 and the 6 at the same time. What's the reciprocal of 5, 6? 6 over 5. If 15 times 6 over 5 sounds scary to you, calm down. Multiplying by a fraction is the same as dividing by the denominator and multiplying by the numerator. 15 divided by 5 is 3, times 6 is 18. And now this becomes routine. I don't even think I want to explain it to you, Yancey. I can't be fluffing your pillows all day. The only thing that might confuse you is that 1/2 right there, but I think you know that to get rid of 1/2, you gotta multiply both sides by 2. But like I said, Yance, you should know that by now. So why am I even wasting my breath? Our final answer is x equals 28. Boy, it feels like this should be the end of the video. But hold your horses, Yance. I got one more surprise for you right here. This little monstrosity has two fractions with different denominators. 3/4 has a different denominator than 1/2. But why do we care about that? Twice now I told you if you want to get rid of fractions, you gotta multiply both sides by the denominator. Well, which one here, Yance? Is it the 4 or the 2? Remember your training! I said if you had different denominators, you gotta multiply both sides by the common denominator. What's in common between 4 and 2? It's 4! So we'll multiply both sides by 4. But we gotta be careful, Yance. When I say multiply both sides, what I really should say is multiply everything by 4. 3/4 times 4 is 3, and then half of 4 is equal to 2. And don't be asking my help for -5 times 4. In fact, I don't think I'm going to tell you the rest of the steps at all, because we've done this problem like 40 times already. Instead, how about I read you a poem? I wrote it myself. There once was a man with some sticks that he used to play drums on some bricks. He played for a score till he couldn't no more, and the answer is -6. See? I'm a master. And that's actually the end of the video. So if you have to, watch it over and over again, 'cause trust me, these problems ain't going nowhere. See you later, Yancey!